Your body, it's doing this incredible, totally invisible balancing act, like every single second, just to keep you, well, you. So today, we're gonna pull back the curtain on this amazing feat. And seriously, I'm not exaggerating one bit. Right now, as you're just sitting there, your body is performing millions of tiny miracles. And it goes way beyond just your heart beating or your lungs breathing. This is something so much more fundamental to you even being alive. So this remarkable thing, this constant, delicate balancing act, it actually has a name. All right, let's get into it. The name for this whole thing is homeostasis. Basically, it's a state of internal balance that everything inside you, from your tiniest cells to your biggest organs, is constantly working to maintain. You can kind of think of it as the stable foundation for your entire biological world. So, what does that actually mean? This isn't some abstract concept. Homeostasis is all about keeping very specific things in your body within a super narrow, healthy range. We're talking about things like your blood's pH level, the amount of glucose or sugar floating around, and of course, your internal body temperature. If any of those get too far out of whack, yeah, you're in some serious trouble. Okay, so how on earth does your body pull this off? How does it fight back against all the constant changes coming from the outside world? Well, the main tool in its toolkit is what we call a counteracting response. To really get how we do it, let's start by looking at someone who does it a little differently. Let's talk about Debbie. Debbie was this awesome pet bearded dragon. She loved to just chill on the couch and get her chin scratched. A truly fantastic lizard. So Debbie also loved her heat lamp. But what happened when she got a little too toasty? Well, what she did was brilliantly simple. She'd just get up, move out from under the lamp, and find a cooler spot. That's it. She regulated her temperature with her behavior. And this right here highlights a huge difference between us and Debbie. See, Debbie is an ectotherm, what we used to call cold-blooded. Her body temperature just kind of fluctuates with her environment. But you're an endotherm, or warm-blooded. Your body works incredibly hard to keep your internal temperature stable no matter what's happening outside. You can't just walk away from your own internal furnace, right? And this is exactly where our main tool comes into play. It's called negative feedback. Now, I know the name sounds, well, negative, but it's absolutely the key to keeping you stable. Here's how it works. Whenever some variable, like your temperature, gets too high or too low, it triggers a response designed to counteract that change and bring you right back to your ideal set point. So let's walk through it. Picture this. You're outside. It's a super hot day. First, these little sensors in your nerves send a message to your brain that's basically like, whoa, it's getting warm in here. Your brain doesn't waste a second. It sends out signals to counteract this. Your sweat glands kick into gear, and as that sweat evaporates off your skin, it cools you down. At the same time, your blood vessels widen up to release heat. And the result? Boom! Your temperature drops right back to normal. Okay, but what about the opposite? Let's say you walk into a building and the AC is just blasting. Your nerves send a whole new signal. Brr, it's cold. Your body immediately stops sweating to hold on to heat, and your blood vessels constrict, pulling blood away from your skin. And if that's not quite enough, you start to shiver. All those tiny muscle contractions are literally generating heat to warm you up. And just like that, you're brought back to your set point. That, my friends, is negative feedback in action. And hey, this isn't just about temperature. This exact same principle of counteracting stuff is happening all the time to manage your blood sugar. When your blood sugar gets too high, a hormone called insulin helps your cells grab it. When it's too low, another hormone, glucagon, tells your liver to release some stored sugar. It's this constant, incredible balancing act. But what if your body doesn't want to counteract something? What if for some very specific reason, it actually needs to crank up a signal instead of shutting it down? Well, that's when a totally different kind of feedback system kicks in. Yeah, this quote really nails the difference. If negative feedback is all about, hang on, let's counteract this, positive feedback is just screaming more, more, more. It's a system that's literally designed to push something further and further away from where it started. So, to put it simply, positive feedback takes a change and just intensifies it, creating this big escalating loop. Now, this is way rarer in your body than negative feedback. Because, for just your day-to-day stability, the last thing you want is for things to spiral out of control. But for a few very specific events, it's absolutely crucial. The classic example, the one they teach in every biology class, is childbirth. Here's how it works. It starts when the baby's head applies pressure to the cervix. That pressure signals the body to release hormones, which then trigger contractions. But, and this is the key part, those contractions create even more pressure on the cervix. This causes the release of even more hormones, which leads to even stronger contractions. You see the loop? It just gets stronger and stronger and stronger until the goal is achieved and the baby is born. So it's pretty clear these feedback systems are, well, vital. But that also means that when they fail, the consequences can be really serious. And understanding how they're supposed to work is the first step in understanding what happens when they go wrong. Let's take a look at a really well-known example, type 1 diabetes. This is a condition where that delicate negative feedback loop for blood sugar, the one we were just talking about, completely breaks down. And here's the specific point where it fails. For people with type 1 diabetes, their pancreas just doesn't produce the hormone insulin. Remember, insulin is the chemical messenger that tells your cells to take in glucose from your blood. So without that signal, the whole counteracting response to high blood sugar is just broken.
The consequence is pretty immediate. You eat something, your blood sugar goes up like normal, but the glucose from that food has no way to actually get inside your cells. It's kind of like having a key, but there's no lock on the door. All that sugar just gets stuck in your bloodstream, totally unable to get where it needs to go.
And this is why it's so critical. Your cells absolutely need that glucose for energy, just to survive and do their jobs. Without the ability to absorb it, your cells are basically starving, even though there's plenty of food, plenty of glucose all around them. And this is exactly why people with type 1 diabetes have to constantly monitor their blood sugar and take insulin manually. They're literally taking over the job of that failed feedback loop. So when you think about it, from the simple act of a lizard just moving into the shade, all the way to the incredibly complex hormonal cascade of childbirth, it's clear our bodies are absolute masters of feedback and control. Kind of makes you wonder, doesn't it? As you're sitting here right now, what other invisible, perfectly balanced systems are working tirelessly at this very second just to keep you, you?